Recording progress.
Okay, good afternoon, everyone. Today we continue discussion on big data, and from this class we'll start talking about cloud computing. In previous class, you had some experience working with Databricks. So as you might see, I guess it was much easier, right? If you just log into a cloud like Databricks and just load your files or like Jupyter Notebook, something like that. More interestingly, even in the previous sessions that you work with the local installation of Hadoop and Spark, or also VirtualBox, it could something similar to cloud computing, because in the browser you put the local host, then port number, and like 9888. So these are like work similar to a cloud, but you connect to some computing center through either your command prompt or your browser. Then okay, let me close the door. So even in the Databricks, I had some similar experiences. So yeah, even in the Databricks, we had similar experiences. So we had to basically use our browser to connect to a computing center or cloud. Then we run some of our analysis, which we just started like doing something like importing data set, printing hello world, those traditional commands. Today we do some review some base language of the cloud computing. Then we do another hands-on experiences, which is using Amazon AWS for doing cloud computing. Any questions from previous classes? So I know this course might look a little tough, but we intentionally want you guys to learn more. No worries about your grades. I mean, we know that it's a tough course, but we want you guys to be successful in the job market. So if you improve your skills and basically learn a lot of technologies, hopefully it would pay off. Okay, so let's just review some concepts first. Then again, at the end of class, we start working with the Amazon AWS. So anyone has an idea about what could be a cloud computing, or what it refers to?
You're using the servers that various companies have, so you get access to much more powerful hardware and all of that.
So that's actually good. But when we use cloud computing, why we don't purchase some platforms or infrastructure in our company and just do everything internally?
Servers cost money, both to set up, and the software to make them run properly together. Generally, hire a guy or a team of guys who are involved. That's also very expensive. Or you just pay someone else. That's also a thing that other things that also
yeah, there's the economy of scale associated with this concept. So especially if you work, you might end up working in a startup. So in a startups, they're usually the business is not that much big at the beginning. So it doesn't make sense to purchase so much infrastructure and hiring so much people to take care of backbone like Hadoop. So even installing Hadoop looks very difficult. Just assume you might get several errors, and so how difficult it is. So they need to hire someone to take care of those errors. Having said that, I mean, I think you already, I think your friend, yes. So you might remember at the beginning of semester, one of your alumnus, I mean, he just graduated last year, and he talked about his job in a startup company. So they use Google infrastructure or Google Cloud Computing, and they applied 120K from Google. So yeah, but after a while, you may think of, does it make sense, or is it economical to pay Amazon or Google, or you just do everything internally? So you can decide about that. But usually at the beginning, it's much more economical to use Amazon or Google infrastructure and do your big computations. But generally speaking, as your friend said, it refers to some resources. It could be the data storage, computing power, or even sometimes software. So let's say Adobe Analytics is kind of a software, it's a cloud-based software that some of your friends are doing competitions. So it could be either ways, but at the end, there is some infrastructure far from you that you connect, and you do your analysis over the infrastructure. And more specifically, at the beginning, when you work in a startup, usually they have some great business idea, and they need to focus on those business aspects of their startup. So for them, it's just much more better to just outsource the non-competitive part to some better companies such as Amazon or Google. So these are under virtualization umbrella, basically similar to VirtualBox that you had, but assume instead of having your computer as a host, there's a host somewhere else that you log in, and they provide some virtual platform or infrastructure that you would be able to do your analysis. So then the most simple or basic or primary type of virtualization is a hardware virtualization. It could be either a desktop virtualization, application virtualization, or basically something like operating system level virtualizations. But anyway, depends on type of your business and the amount of automation that you want. They might give you more sophisticated virtualization. Have you ever worked with the Clark cluster? I'm thinking maybe, let me see, if we have time, I will teach you how to use a cluster, especially a Clark cluster. Again, I love you guys learn about that. So basically in Clark cluster, they have so many computing power somewhere in Clark. So you need to use command prompt and send your code there, run, and just get your results back. So it's not that much user friendly. You need to type everything. And basically, you need to have your your codes. You should test it before that. So maybe on your computer, you run with a much smaller data. And when you see your codes works, you can work with a much greater data set and just send it to the cluster. If you have time, I will cover that. I think it's a good skill for you guys to learn. Okay, this is the general schema of hardware virtualization. Basically, you have a hypervisor which controls all those virtual hardware. So within a host, you might have several virtual hardware. On top of each virtual hardware, there's a guest OS or a guest operating system, and on top of the operating system, you have some applications. So basically, it's similar. It's like, if I make it in a simple way, it's like you use your browser and connect to a service, and you see a desktop. So it might even similar to Windows desktop. So generally speaking, containerization refers to operating system which it has some sophisticated kernels, and on each kernel it runs basically an operating system. So one of the most common applications is running deep learning. So if you might remember in the previous class, I show you deep learning is a complicated neural network which you have several hidden layers. So adjusting right weight in each link of hidden layer takes a lot of time. So usually if you have a real industrial-based deep neural network project, usually it's better to use some clusters or like Amazon AWS or Google. Usually it's not, you won't be able to run over your own system. So you might remember another alumnus, Gurpreet. So he had a startup and it was about deep learning image processing. Most likely they're using some outsource based virtual system. Even I assume it could be containerization. I will check with him to see if he might be available or not. If he would be available, ask him to explain more. But oh, by the way, is there anyone in this class has my 7 p.m. class today? Okay, so I invited like alumnus. So if you are not my midnight, shouldn't I say midnight? It's very late. So it's 7 p.m. class. So you can attend the class. He's working in this area in the healthcare. So you can ask him about how to be successful in the job market. Even you can check if there's an internship or full-time job available in his organization to be able to join. But anyway, I think it's a good experiences that he has a good experience that I could share with you guys. So we have 3 major cloud deployment methods: private, public, and hybrid. So there's some minor methods too, but these are usually the major ones that make sense for everyone in the industry. Private cloud is like your own organization. Just have, let's say, Amazon. Let's say you work with the Amazon. So they have a clouding service for their own company. So everyone in the company can send the data to the cloud and get it back. Similarly, you might end up in a company that has several offices, but maybe in 1 or 2 offices, they have great infrastructure and you'll be able to use the cloud internally. Or even, I think Department of Defense has a contract with Amazon, so they ask Amazon to provide a private cloud for them. So, or there's some other organization that reach Amazon or Google, so they ask their expertise to set up a private cloud for those organizations. So the other one is the public. So for sure, it should be, in terms of cost, it's much cheaper than the private one. Basically, there's a shared computing power, usually based on first come, first serve. It might be some constraint in terms of how much power you can take, but basically, it's just shared resource that everyone can use it. So the concept is similar to cloud cluster. So some people use the cloud cluster. They send their codes to the Cloud University cluster, and there is a queue. So first come, first serves, and just they wait for the next one. So we have a private cloud in the cloud, but the computing power is shared. For public cloud, it just means it's not shared internally, it's shared out between different companies or entities, and they basically can reach and run their code. So have you ever worked with the Google Colab? So Google Colab is a shared one. Also, let's see if you have time, but if you have time to work with Amazon AWS, it's a shared one. Many times, most of them, not most of them, many of them are free. So they shared some free-based services. So people can, it's not actually, it actually has some advantages for them. So you guys you and everybody else might be interested to work with them, the free version of their services, and learn how to use it. So later, if they learn and they happy with the service, maybe they pay for the private version or the paid version for your organization. So hybrid cloud, so it's usually for the mid-sized organizations. So they might have some part of the computation could be done through a private cloud. But if they increase or the size of the business increases, they might reach for some shared-based computing power and outsources from out of the institutions. Okay, we have 3 or 4 major cloud computing models. So we talk about different, basically division of cloud computing. It might be based on deployment models or computing models. So we have different types of methods or modeling. So the services that you get, it could be infrastructure as a service, platform as a service, software as a service, and data as a service. So I think infrastructure and data as a service makes a lot of sense, but what's the difference of platform and software? So basically, platform is the collection of some softwares, or it could be even some platform that lets you to make some reports or basically create some applications. But service and application is usually in the higher level. They are usually more specific type of software that are purposed for some certain task. But the border between platform as a service and software as a service is very narrow. So infrastructure as a service is like they provide you some RAM, CPU, and maybe storage services that you can install your own OS, and basically it's like having a very complex computer somewhere in the cloud. So platform as a service is just basically is the most well-known and maybe the oldest computing models. So basically, an organization provides a platform for doing some analysis, making some reports, and using a set of or group of technologies. Facebook, Moodle, AWS EMR, these are example of those platforms. So basically, on Moodle, I can log in, see your grades or assignments, and provide some PowerPoint and make some reports. So your access is different from me, so you might be able to upload your assignments, look at your grades, and get your own reports. The next service or computing model is software as a service. As I said, is more they are focused on more specific goals or targets, and I think you already have experience working with the Microsoft Office, Amazon Web Service, Google Apps, Dropbox. These are software as a service. This figure shows you the general hierarchy of those models. So in the lowest level, we have infrastructure. On top of that could be a platform. Application or software could be built on top of a platform. Any questions so far? be a question, so let me see. Oh, today you mean? I said, so Arjun, you said about the today presentation?
Yes, Professor. The alumnus you just mentioned about.
Okay, so his name is Efrat Islam. He's working in the healthcare industry.
Thank you.
So let me just wait one more minute. Your friend over Zoom might have some questions. Okay, the last computing model or service model is data as a service. I'm not sure if you have some experiences working with that. Have you ever worked with the Bloomberg? Okay. So you get the data from some organizations like Bloomberg, or I work with the CompuStat and Bordex. So basically, I log into a organization and get like all of the basically top 500 US companies in terms of the financial reports or board member reports. Usually in the data as a service, there is a certain valuable data that gets updated. So those organizations do a lot of effort to update and maintain the data. So anytime you connect to their platforms and download the data that is relevant to your case. So let's talk about big data analytics on the cloud. So Amazon AWS, Microsoft Azure, Google Computing Engine, Google Cloud, IBM Cloud. These are major providers of infrastructure as a service, platform, and data as a service. So they're getting a lot of popularity because, first of all, if especially you end up working in the startups or you make your own startups, at the beginning you're not sure how much computing power or how much expertise you need. So you can buy certain services that fit for your needs and is highly scalable. So when your business gets larger, maybe you can scale up your computing power and just get more resources from them. Then up to one point, you might decide, is it better to mix everything internally or still use cloud services? So in this class, we have time for Amazon Web Services, but the remaining like Azure, Google, IBM are pretty similar. So you need to make an account and you specify some hardware, software, and RAM and other hardware specification that you want. Then you install Hadoop, Python, and then run your codes. So there is a Hadoop ecosystem that includes several technologies that or components that work together and makes your life easier in terms of running your MapReduce. But depends on the organization that you reach, either Google, AWS, or IBM, they have their own version of Hadoop. They're pretty much similar to Hadoop ecosystem. If you know one of them, pretty much you can do over their platforms, but usually we refer them as the Hadoop flavors. It's just because all of them has access to Apache Hadoop, which is open source codes, and then they can adjust based on their own implementation or their own needs. So at the end, all of this concept would work. So you might remember we had some experience with Hadoop HDFS directly. Then we learned how to have Yarn, and on top of Yarn, we be able to install Peak, and we just made some simple Peak codes, and also we started to work on a Spark. So in Databricks Hadoop flavor, you don't need to be afraid about Hadoop HDFS, Hadoop Yarn. You just directly use Spark. So for Amazon type flavor of Hadoop ecosystem, you still need to do some installation on your own, but it's still much easier and much faster if than you do it on your own system. But at the end, this is the general concept. Based on the organization that you reach, you might have less duty on your own, or maybe you pay more or less, depends on how sophisticated is their service. Okay, so I have a question. Last time we worked with the Databricks. Do you think, is it a private or hybrid or shared or public service, computing services was? What type of model we had? So it was it was a public shared model, because everyone can use it and it's shared for many people. So if there's not too many users, it's fast. But if so many people suddenly use Databricks, it might get very slow. Same for Amazon, which we do it today. We use a public version of Amazon, AWS. So hopefully there's not too many people are using it at the same time. So otherwise it might get somehow slow, but usually it's not. It doesn't happen. I think we talk about okay, this is your next assignment. When should we buy a Hadoop infrastructure or use Hadoop Cloud? And just discuss maybe on one page, and maybe you can just Google and search for it. Also focus more on business and practical aspect of these investments. So either you use Hadoop Cloud or you just have your own infrastructure. You need to pay for that, but it depends on some factors that we discussed a little bit. Okay, any questions from you guys or people over Zoom? Okay, so if there's no question, please download the next PowerPoint. If you're working in a group of 3, most likely you need to know about that, but I think for the remaining of you might be kind of optional, because you don't have to. But if I was in your shoes, probably I try to learn how to work with AWS. It's not as easy as Databricks, but it's still much easier than local installation. Also, we are using a free version, but still you need to still provide your credit card information. So if you don't have your credit card right now, no worries. I record this video and maybe use it later. Also, if suddenly we get a stuck because of AWS public thing, there's no issue. I make a video and just upload it later, so you can follow the remaining sections. Also, we learned the free version, but if for your project, they used to give $100 credit. I remember when I was a student, I used $800 because I forgot to turn off the instance. So there's a Amazon term for using the infrastructure. They call it Amazon instances or EC2 instances. So I forgot it was running for maybe 2 weeks, but they told them I'm a bankrupt student or broke student. Please forgive me, and they forgave me. But there is no guarantee that they forgive forever. So in case you need it for your final project, just keep in mind, don't just leave your instance forever. Just terminate when you don't need it. So is there anyone from people over Zoom or class who tell me why we learn Amazon AWS? What's the point of learning Amazon AWS?
It's nice to know another tool, yeah, at the very least, that it's gonna be useful to be able to know how to use.
Yeah, there is one conceptual reason and another like business reason. So the conceptual, we want to learn cloud computing instead of just memorizing everything. We want to have hands-on experiences. So connecting to cloud services and do basically some installation and learn how to do that. And second, if you might end up working the startup that they need to do a lot over Amazon AWS. And I'm also would want to talk our department for making more technical or bring more technical issues in your courses, because we had some of your graduate students. So they went to work in some companies and they asked them too much of coding. So just keep in mind, in some organization they need some potential coding experience or coding knowledge from you. So even I remember I had interview for internship in Google, and after saying hello, how are you, they asked me to do some coding. So it's like they gave me a problem and let me to do that. So it might make your course a little more difficult, but I guess you might be mad at us, but I think as long as you improve your coding and your grades would be good at the end of the semester, that's worth it. So for Amazon AWS, I let you know how to install and run your code, but just keep in mind, I don't have enough time to cover every coding aspects over AWS. You still need to spend some time. Let's say, just assume maybe one point in future, somebody asks, just ask you to sit on a computer, you don't have any power for nothing, and ask you to run some code over AWS. So I won't ask you to do that, but just keep in mind, have those skills ready on your side. Some companies might be very nice. They don't require you guys to be ready to do some coding, but many companies recently they do, especially if they have good businesses or very large institutions. So again, no worries about your grades, but we intentionally want you guys to be more technical. So please be ready for some technical aspect in this course. So in the previous class, we actually had our first hands-on experience working with the cloud computing. And as you saw, you need to just make an account, log in, upload your data, and start coding. Now we are learning how to do something similar with AWS, but when you work with the AWS instances, you need to do further in depth. So you need to set up some of your infrastructure and platform. So again, most likely they won't charge you, but don't forget to terminate your instance after the class or after running for your own project. So today class, we set up Amazon Elastic Computing Cloud, EC2. So it provides a scalable computing capacity or resizable over Amazon infrastructure. So in some certain point, you would see we are using the free version, but if you end up working in the industry, instead of picking the free version, you pick the highest computing instance. So since I already have an Amazon account, I already had Amazon AWS set up, just pick this link, Amazon AWS free, use this link and create an AWS account on your site. create free account. So yes, just do that. I give you like 5 or 6 minutes to do that. So the steps are similar to making an email. So you need to provide your email address, password, user account, and I just hided my credit card because I don't want to share it with you guys. So, and at the end, just pick the free version. Although you provide your credit card information, but just pick free instance. And hello again, everyone. As you might know, during the class, I couldn't finish AWS setup, so I made a separate video and attach it to the previous one. So from this point, you can pause anytime that you want and basically just catch up with the video. The steps are pretty easy, similar to local installation of Hadoop, Spark, and Peak. So we get an instance over Amazon AWS. What I mean instance, just as an oversimplification, is similar to have a computer over Amazon cloud. So that computer you can request a certain operating system, and over that operating system, you need to have Java, Scala, Hadoop, Spark, and Peak installed. Having said that, first you need to, after setting up the account, which I already explained, and again, all the steps is already on the PowerPoint. So copy this address, AWS Amazon console, paste it here. And on top right, there's a sign into console, click on it. Use root user and the email address that you use for making the account, press next. And just type down your phrase. For me, it's 4WDM7Y. Submit. Enter your password. Sign in. Okay, so this is your AWS Management Console. So on the top right, you see my account, Hamid Online Clark, and I have account ID. So for you, it might be different. Okay, this session is for setting up EC2 instance. So go over services, into services, under compute, just pick EC2. As you might see, I already have an instance that I terminated. And you may not see a terminated instance if it's your first time. No matter if it's your first or second or how many times you use this platform, after termination, it might take a while, so your instance would be gone from here. But anyway, for now, press Launch Instances. So first step, over EC2 instance, we need to pick our operating system. To avoid getting charged, you can get the free tier eligible type operating system. So there's an Amazon flavor of Linux here, iOS, SUSE or SUSE, and Windows. I picked Ubuntu because it's one of the most common server-based operating system, and you can find quite a bit tutorial, or whenever you're stuck, you can just Google it, and probably there's a good community that can help you. So I pick Ubuntu Server 20.04, select here. I stick with the free tier, but again, you might end up working the startup that for an industry-based project, you need to have a better or more power for your computation. So here I have 1 gigabyte of memory and 1 CPU, but as you see, you can just get a pretty strong, easy to examples like 192 gigabytes of RAM and 96 CPUs. But the steps are pretty much similar. I just picked a free tier one, press configure, and I just want one sample or one instance. And in this course, I don't have that much to go over all the details, but if you're interested to know what does, for example, IAM role means or what does placement group means, take your mouse over there and you get some description. For some of them, there's a learn more, and when you click on it, it provides further information for you. If I just recommend to spend a little more time, play with these options, and just go for further details. So I click add the storage, and 8 gigabytes of storage is more than enough for my calculations. But again, you can raise it more space, more larger sizes, you should pay. So then I press add tags, and I need to create a tag, so a key and a value. So for key, I just randomly pick key class. Let's just name it 2021. Value class 221. Then press configure security group. So in this section, you identify any type of connections, protocols, and like sources that could connect to your instance. Again, what I mean instance, it's just like a computer that you're setting up over Amazon Cloud. So for type, I just want to pick all traffics and sources anywhere. But I can limit the IP's good access and type of connections. I'm just reducing my security, but I mean, this is for learning purposes. Click on preview and launch. This is all information related to my instance, like the operating system, CPUs, RAMs, protocol, the tags that I use. Then I press launch. Okay, now Amazon just created a Keypair for me. It is just a key file that you download on your system, and you can access to the instance through that Keypair. I already have some existing Keypair because I work with the Amazon AWS, but if it's your first time, you can, instead of using existing Keypair, maybe create a new one. You can just pick a name, so maybe Keypair class. Download Keypair. Okay, I already have something similar. Let me just pick another name. My class key. Again, since I already created several Keypairs, so it just told me I should pick a new name. So I pick this name, my class key. Then just launch your instance. So you can go over services and just go over EC2 instance, but also here we have a short key. You can just click on this instance ID. The situation is pending. It might take like a few minutes. So your instance with the operating system that you pick could be work properly. Meanwhile, if you are a Windows user, you need to convert key to a Windows-friendly format. So it's running right now. But if it's your Mac user, by the way, I put all the steps here. So in case you need to take a notes, you can just use these PowerPoint files, but everything is there. Okay, so if you're a Mac user, you can connect to your instance through your command prompt, but you need to use these two lines. The first line is your the key file that you downloaded. So my previous key file was a Spark Key 1 PM, but right now I have another name. And also for the second line, you need to edit it. First, you change your key name. Let me go to download first. So my now new key name is my class key. So here, instead of Spark Key 1, I should change it to my class key. And again, the red part should be changed. The second one is my instance web link. So how you can find it? So if you go over your instance and just click on the instance ID, this is the general information related to your instance, like your ID, and the most important one is public IPv4 DNS. This is the address start from EC2 and ends to Amazon AWS.com. Press copy, and here you can just paste it here and change it to your own address. So whatever you see in the red here, it might be different on your system based on the key that you just downloaded from Amazon website, and also your a specific web link that you can find it here, and it's different for everyone. So the red parts could be changed on your system. So, but for Windows user, you need to convert the PEM file to PPK file. So you can use your command prompt to connect to Amazon AWS. For this purpose, on the search bar, search for PuTTY or PuTTYgen. This one. So it just needs two steps. First, you load the Keypair that you just downloaded. Let me find it. Okay, here you should change to start.ppk to all files. Now you can file myclass.pem. Open. Just press OK. And you don't need anything else except for saved private key. So press on it, press yes. And just change it to the name that you want. So I want to just keep the alien name. So my class key dot ppk. That's it. Okay, so now I can use PuTTY again, or PuTTY, and put the key and other information to be able to connect my Amazon instance. But keep in mind, your instance state should be running. So let me go back. So it's running. So I can connect to my Amazon instance. So in this search bar, just search for PuTTY. Okay, first you need to identify your host name. So my host name is Ubuntu. Add. After add, you should put your web link. So how can you find your web link? Just click on your instance ID, and you need to copy this address. So here on the click on copy button, it's copied. After add sign, you paste that web link. You can pick a name, so Amazon, maybe try, and any random name should be fine. So later you can use this session that you saved, and you don't have to just enter all the information. So you can save it here. I press save. On the left side, now we are in the session. So, but go to connection, then press SSH, expand it, and click on AUTH. In this section, you need to load your PPK file or the pair key file that is Windows friendly. So first it was PM, we converted to a Windows friendly format. So you browse, then Just click on my class key.ppk, open. So now everything is set. You can just click on open. If you put everything right, it might take like 1 or 2 minutes to be able to use your pair key information, also host name, to connect to EC2 instance that you have on your Amazon. So here, press yes. Now I connected. So far I have an instance on over that instance. That instance has the CPU and RAM, and on top of that, I have an Ubuntu operating system. Similar to local installation of Hadoop and Spark, you need to have some software set up on your system. It includes Python, certain Python version, Python packages, and Java, Scala. Scala is basically, you might remember Java is the core of Hadoop and Spark, and on top of that, Scala is the original programming language, but you can just use Spark, PySpark, or Spark R, so you don't have to learn Scala to be able to code and do programming using through Hadoop ecosystem. Okay, but what software or packages I need to install? So if you go to this section of PowerPoint, I put all of them here. It's just including updating your apt-get, installing pip3, and like Java, Scala, Hadoop, Spark, those things. Before that, maybe you can just enjoy working or playing in this environment. So just type Python 3. So between Python 3, there's no space. Press enter. Now you're inside Python environment. Maybe let's just print hello world, which is the traditional command in almost any languages. So I type print, parentheses, quotation, hello world, exclamation mark, colon, parentheses. So you can make some for loops or any other Python commands that you know after playing this environment. I mean, you can pause the video, type quit, parentheses, and you can get back to the command prompt. Let's install this packages, softwares, and platform one by one. So just here, you can do copy, and within command prompt of putty, just right click, and it just goes in almost in autopilot way. So let's just copy the second line, get back to putty, right click. It's asking me some questions. I just press yes for all. Then let's install Jupyter. Then I install Jupyter core files. Right click. Yes. Let's install Java. Copy this one. Get back here, right click. Yes. You can check your Java version to be sure if it's installed correctly. Yes, I have Java version 11. So let's install a Scala, which is a programming language. Yes. Can check our Scala version. So now I'm sure it's already installed. So let's install py4j. Right click. Okay, next command. Similar to local installation of Spark and Hadoop, I need to reach Apache website, and over Apache Spark project, I download the Spark files. So this Spark is Spark 3, which is built under or over Hadoop 3.2. So TJZ is a kind of compressed file. So I copy here and paste. So it should take at least like some seconds. If it just goes very fast, it seems that you haven't installed properly. After downloading the compressed file, we need to decompress. So the sudo tar lets you to decompress this file. Ctrl C, Ctrl V. So now I'm decompressing the Hadoop file and Spark file that I just downloaded. Next step, let's check if we have the folder. So I cd Spark 3.0 bin Hadoop. So I want to see if, yeah, it's there, and I can just run pwd print working directory. Yeah, this is my home Ubuntu Spark 3. This is my working directory. So with cd command, I can get back to the root folder. And now I install find a Spark package. This is a Python package that helps you to work with the Spark. pip3 install. Okay, so if you leave and exit this command prompt and you want to get back later, run this line, Jupyter Notebook generate config, but it's more efficient to just keep working, and we want to do some configurations. Ctrl C. So I want to make some certifications and also add a key file, pair key file, similar to my class.pm that I downloaded. So first, we make a directory of certs. It's a stand for make directory, so mkdir. Let's get to that directory. Now I want to make a Keypair file, sorry, and also put some configuration in it. So with this command, you make that Keypair file and you can write the configuration within it. So when you're in the certs folder, just paste that command. It asks you some default questions, like which country. You can just pick US, state, maybe MA, Massachusetts, and you just can skip the remaining. It's not that much important. Okay, now we need to basically change our Jupyter Notebook configuration. So I go cd Jupyter. So I'm within the Jupyter folder, and with this command, you can write the configuration settings. So Ctrl C, right click. So now I reached to the configuration file. As you see, there's so many command lines in blue. It just means there are comments on. They're not actual commands. So if you press I, Now you can type some configuration within this file. So I press the arrow key, I get to one space that I can paste the configurations. If you get to the next page in your PowerPoint, you see some configuration, for example, the IP address, the port information, and other information. So just select R, Ctrl C, and paste them here. Now I put all configurations that I need for working with the Jupyter Notebook. So now we need to save the configuration. As you see, I put the information here. When you're in this configuration file, just press ESC on your keyboard, then type colon WQ exclamation mark and press enter. Okay. You can press CD, you can get the root folder. Now we need to log out of this PuTTY command prompt. You can just exit it, or you just simply just close it. So after getting back to the root folder, just press on exit button. Press OK. Again, reach to your PuTTY. I have AWS try because I already saved it. If you didn't save your session, just go back to the steps and you need to load a key file and also change your session information. I already put my host name information, so I select AWS try that I already saved. If you didn't, you need to go back and do this step again. So you need to load the key and put your host name, those information. So I select the session information that I already saved. I press load, so I have those information here. I go to SSH, ATH, and browse to the key that I created. My class key, open. Then I press open. It might take like some seconds to reach to your instance. Yeah, I'm in it. So now go to cert directory for your configuration certificates. And here, just type this code, sudo chmod 777. We type CD to get back to the root folder. And now you can type your Jupyter Notebook. Congratulations. So now you set up a Jupyter Notebook and it's accessible through Amazon AWS instance. So what does it mean? So if you want to do some PySpark codes, you can just simply reach the notebook that you created and just type it there. So it's much more convenient than working with the PySpark directly. Similar to Python. So if you might work with the Python directly, or you work through the Jupyter text editor. So as you see, it put some information. It told me how to connect to that address. Let's just copy this one. When you highlight the text, it automatically copies. So go to your browser, just paste it here. It doesn't go to that address. The reason 127001, it just means local system. It's not in the local system, it's over Amazon AWS. So instead of 120.0.0.1, you need to put your IPv4 DNS address. So again, get to your instance and press copy here, get back to here. And instead of 127.0.0.1, just select and replace with your IPv4 address. So now I'm saying that okay, you can reach to that Jupyter notebook with this token address over this computer. So again, 120.0.0.1, it just means local computer. Instead, you need to put a web link address, which is created for your specific instance. Press enter. So it's a weird HTTPS address for your browser, but that's okay. We can trust it. So press on advanced and just here select proceed. Congratulations. Now you're within a Jupyter notebook that is running over your Amazon AWS. Instead of using a local system, so you need to buy some hardware and hiring someone to set up a local instance. Some certain operating system. Here we use Ubuntu. So first step, we got our instance or your virtual computer. On top of that, we install Python, Java, and other packages. So we'll be able to basically have all prerequisite. On top of that, we built our Hadoop and Spark. And now we are within Spark environment, or actually it's better to say now we have Jupyter text editor to be able to run Spark codes, more specifically PySpark, over the instance that they have on Amazon. So instead of having 127.0.0.1, which is just means local host or local system, I have my web link. So you can press new Python 3. And just type a simple Python code like print hello world. Voila. Now we run our first Python code through Amazon EC2 instance. I put an assignment for you. For some part of this assignment, you need to Google and find the way, but I already taught you the first two, how to create AWS account, so how to run Jupyter Notebook over AWS EC2 instance. So for third step, maybe you need to Google a little bit. So you need to get data from MobileLens 100K. Maybe one way I told you to use wget. So here, we have wget to download the file and you learn how to unzip it. But you also can directly download by using just Python code. So you don't have to use Ubuntu system, but you are more than welcome. Then find the user rating, the mean of user rating or a star. So instead of mean, let's just make mean means average. I think mean is super easy. So find the mean of user rating stars. Okay. So I give you quite a bit of time. So I think you can, if you Google it, you can easily understand how to download the file, unzip it, which I already taught you in this video. And you can just bring that file into your Python environment. You find the user rating column and just find the mean or average of user rating and star. So for this assignment, I want you guys to just make a Word document and take some pictures from the steps, like how the steps that you create an AWS account, the steps that you set up Jupyter Notebook, and also take a picture of your Jupyter Notebook over your local instance. So I shouldn't see local host or 127.0.0.1. I should see your web link. And then just submit it and also submit your Python code. So 2 submissions, one Word document, the second, your Python code or the Jupyter Notebook output file. So you can go here, file, and save as, or I think maybe it's easier to just download that. So you download as a Python py or notebook IPYNB. Both of them are fine. So either Python or a notebook IPYNB. Thank you very much. That's for today. And sorry for you couldn't have enough time. When I do in-class in-person sessions, it might take some more time because people have some questions. Thank you very much and take care. Okay, I just left with one more thing. So as I said, we are working with the free tier, which is like free version of EC2 instance over Amazon Cloud. So, but it's a good practice after working with your instance, just terminate it. So you would be avoided from getting charged. When I was a student, I think I forgot to turn off my instance and they charged me a lot. So I just told them I'm just a student, I need it for my class project and please forgive me. And they forgave me, but there's no guarantee that they do it forever. So read documentations about how long you can run the free tier version of EC2. But again, it's a good practice to just shut it down after your root user. So here I'm in my instance page, but if you just lost it, when you log in into your AWS, just go to the services and under compute, go to EC2. Select your instance, then go to instance state and select terminate. So as you see here, your instance is shutting down and you're good to go. Again, that's for today. Please practice installation and run your own code. Again, if you're in group of 3 on top of Databricks, which is the most easiest platform for running big data PySpark codes, you need to have another platform. Either could be local installation or using another cloud services, which Amazon AWS is one of them. Okay, that's for today. Have a good rest of the week.